technical problem. So this is a little bit of mechanical engineering with some gears and stuff. It's kind of cool. How do I zoom down? So there we go. All right. So basically in this task, we have a more complex structure. We have this 2 gears and this belt. Okay? And there's different types of belts. They have different pitches, different tooth height, different belt heights, etc. And the thing with this is that we need to be able to represent this in our code. Now, for example, one belt here has all of these parameters, or what would you say? It has these values, okay, that describe it. But the problem with this is that how would I group these together such that I just want to describe AT5 but have information here? Okay, and this is where a struct comes in. Okay, it's a little bit similar to an object, but not quite. It's kind of can be seen that way, but it's a structure, so it includes multiple bits of information. And this is really handy for describing complex data structures, such as a belt. Okay, a belt is not an int, it's not a float, but it's a collection of different data types. Okay. So that's the first thing. Okay. And what are we doing in the first part? We're actually going to. All right, cool. All right, so in the first part, we're just getting information from a user. Okay, so we don't have to care about calculating the size of the belt at this stage. But I'm going to give you this part now. Cool. All right. So here we now have a simplified model of our system. So we have one gear, another gear, the distance between them, and then the belt would go around that. Okay. Now, in terms of what's happening here, we have a whole bunch of stuff happening. Okay. And they're not simple data types anymore. Okay. So I've already designed the structures for you that you need. Okay. So we need gears, okay, which have both a diameter and a pitch. Okay. We have a belt, okay, and the belt itself has a type. Okay. And then we have the entire system, which includes a belt, 2 gears, a center distance, and also the belt slack. Now, don't worry about the belt slack too much right now. We'll talk about that later. But you can see how this whole system is built of more complex data. Okay, so you've got this belt, which isn't just an int anymore. It's another struct inside it, and that includes a bit of information as well. And that's made up of a string, an int, a float, and a float. This is made up of an int, this is made up of an int, and the system is made up of 2 bits of complex data and 2 simple bits of data, which are just 2 floats. Okay, and we can see this system here. Okay, so with our structs, they can be in arrays, they can be pointed to, they can be used like a normal data type. Now I'm going to show you a couple of things with this because this is where most students get confused. All right, so let me go here, and copy this across. Let's go to the steps. All right, so the steps. Oh, look at this guy. So you would have seen that with the assignment, except for you would have had 11 decimal places. Now, you'll notice this as well. We've got string.h. That should be a lowercase s. I need to fix that. And then we're going to create the structures. Now, the way I like to do this, and this is the way that I usually design stuff, is I like to design all the structs beforehand, such that they just act as a new data type rather than creating them when you're creating a variable. Okay. I think this just makes it easier. And this is the way that I'm going to do it. But Rick shows some alternative ways in the lecture, so you're aware. Okay. So what I do is you've got your hash includes, blah, blah, blah. You've got your hash defines. Then here, you'll have your struct definitions. And then below that, your prototypes. And then below that, main. And then below that, your functions. Okay. And this is usually the way that I will lay it out. So let's go have a look at one of these, and I'll probably pick one that's easy. The gear is probably the easiest one, so let's do that first. Now, structs are a little bit difficult in memory, so we're not going to worry about them in memory for this subject. They're actually a little bit more interesting. If you're interested, you can look it up, but don't really worry too much about it. So this is what a definition looks like. Now, this is not a variable, okay? And this is really, really important that you understand this is not a variable. It's just a definition of this struct, okay? So you can think of it like a template or a data type, okay? So for example, we've got int, that's a data type. We've got struct gear spec, which is another data type, okay? So what we're going to do now is we're going to go into main. We're just going to have a play with this, and then we'll continue back with the lab. Because this is kind of important, and this is where most students get confused. But if you understand this, it makes it so much easier. So we've got int main, blah, blah, blah. Anything else? No. All right, so let's go back to week 1. Int a. Okay, now I go back to this quite a lot, and I did this with the pointers as well, because a lot of things revolve around this concept. And if you understand this well, and I know it seems so simple, but if you use the simple things to help your knowledge of the more complex things, it makes things so much easier. And the same applies with physics, biology, engineering. If you understand your fundamentals, then you understand everything. And this is why in engineering, We focus so much on the fundamentals rather than the really complex stuff, because if you have a good understanding of the fundamentals of physics, mathematics, programming, logic, problem solving, you can solve any problem. And same with IT and communications. If you have a good understanding of maths, programming, memory, server architectures, etc., and networks, and all the base fundamentals, then you can create anything, and you become unstoppable. And you become very, very employable as well. So here we have type, and then we have the identifier. Okay, and then a semicolon. And that's it. That's a declaration. Okay. Now, this is the most common mistake that students make when using structs. Okay, so this is our data type. The type here is struct gear spec. Gear specs. Okay, really should make that. Whatever, doesn't matter. And then the identifier might be gear 1. Okay, so here I've created a variable called gear 1, and its type is struct gear specs. And this gets really confusing for a lot of students because they're like, there's a bloody space in between. How does this work? Okay. And it gets really annoying because we've never seen a space in the middle of a type, but this type has a space in between it. Okay. The struct is part of the name of the type. Okay. And it's important that you don't get scared by this space here. And a lot of students do, and they'll just write gear specs, but it's not. Okay. The whole type is struct space gear specs. Okay. Now, our gear 1, we can use it like a normal variable, but it has some problems. Okay. Or it has some features more so. Okay. It's not an int, it's not a double, so we can't do something like this. Gear 1 becomes 2. Okay. It won't work. But it has 2 ints inside it. Okay. So it has 2 ints inside it. And we can, yes, you can use a type def, but I'm not going to go into that because I think it's better to understand the syntax rather than simplifying it to get rid of the understanding of syntax. So if you're comfortable using type defs, yes, you can. But I actually prefer teaching it without type defs because I think it adds to the understanding of syntax. So it's just a question in the chat. So now I forgot what I was going to say. My nose is itchy. All right. So what we're doing here is if I wanted to set, say, gear diameter to 4, I can do that. And this is called accessing the member. Okay. So you write dot gear diameter. Okay. And I can put 2 in there. And then I can go gear 1 dot gear pitch and set it to 4. Okay. And I can create another gear if I wanted to. Okay. Just like any other variable, I can do this. I can also initialize. So I can do something like this. 4, 4. Okay. And I give it the values 4 and 4 right from the start. Okay. So if I wanted to do a printf, I can do that. Okay. And I could do printf %d gear 1 dot gear diameter. Okay. Does that make sense so far? Now, if I want to do a scanf to store stuff in here, with this, you need to be a little bit more careful. Okay, so with the scanf, we want to store the result in the gear, let's say gear pitch. So here I need the address of, and I'm going to use brackets. I'm going to say gear2 dot gear pitch. Now, the reason for the brackets is because I don't want the address of gear 2, but I want the address of the pitch. Okay? So this is something you need to get careful with and be careful with. All right. Is that making sense so far with structs? Okay, so it's just a special data type that can have multiple types inside it. And we'll talk about arrays. So if it's making sense, just thumbs up, a little animal, or yes. Cool, cool, cool. So because this is just another data type, we can use it like we use it for creating arrays or really anything like we do when we use any data type. So actually, we'll go back to our basics. So if I want to create an array, I can do something like this. Okay. And here I have type, the identifier, and then the size of the array. So I can do the exact same thing with my struct as well. So I can do struct gear specs, and then I need to give it a name. A lot of people forget about this. I'll call it gears, and then 3. Okay, remember that this big thing here is the type. Okay. Then we have a space, and then we have the name, and then we have the brackets. Now, this gets a little bit more confusing because now we have 3 things in an array that can have 2 things inside them. Okay, so each one of these gears can have both a diameter and a pitch. Diameter, pitch, diameter, pitch, diameter, pitch. Yeah, which is really, really powerful and really, really handy because most objects in the world can't be described just by an int or a float. And we don't want to have to create these complex data structures that we need to make sure that these two are together. Okay? These two will always be together. They're both at index 0. They're both at index 1. They're both at index 2. So they kept together and we don't have to worry about them. Okay? So this is the really nice thing about structs. Now, if I want to, let's say, set... Now I've lost my pen. It's gone crazy. If I wanted to set, let's say, the pitch of index 0, then I could write something like this. Gears 0 dot gear pitch becomes 4, let's say. And I'll set it to 4. Gears 2 dot, what's the other one? Diameter. Diameter 2. That'll set that to 2. Okay, so we can use arrays as well. Does that make sense? Cool. Now let's talk about strings. Okay. So early on, we would have seen this, %s, okay, which is a format specifier for strings. Okay. And we haven't really used strings that much so far. But let's say I've got something like car, a, hello. Okay. Now, this string, and this is the important thing to really understand, okay, and this is the fundamental thing that defines a string and how it works versus a collection of characters, okay, is 6 characters. Okay. Now, I know you only see 5, which is the H, the E, the L, and the O, but all strings, okay, will always have a null terminator at the end, which is /0. Okay. And when you use these double quotes, it automatically always adds that to the end. Okay. And that is important for strings. Okay. Because it tells us where the end of the string is, and it tells us a lot of information for our strings. And we need to keep this in mind when using strings. Okay. So why I'm saying this is because we're going to use scanf with strings in this problem. And we're also going to do a string compare. So our scanf is going to take a string, okay, and we need to create that string beforehand. And it says it needs to store 5 characters. And you'll notice the options are AT5, AT10, AT20, which are only 4 characters long, but we need to store that null terminator. Okay, so car, I'll just call it str for now, and I will make it 5. Okay. And then here, I can just put string. Now, why does that work? Okay, I don't need the ampersand here because, remember, str points to the start of the array. Okay, so it tells me this is where my string is going to go. Okay. Now, there is one other thing we usually do with scanf with a we're not doing get s, so that's fine. Don't worry, actually. All right, so the next thing is with printf. When we use %s, yeah, we print out string. If it has this here, it'll work perfectly fine. And when we do a scanf, it will get it perfectly fine as long as we've got that extra space to store that character. If you don't have that character here, the null terminator, and this is not null, it's the null terminator, the printf doesn't know where the string happens. And what happens? So let's say we didn't have a null terminator here. What it'll do, it will do one of 2 things. It will either print hello and then random garbage and then crash, or it will reach another null terminator in the data, which is usually, well, not usually, it is a 0, and so it will stop at that and print hello, a bunch of garbage, and then stop. And there are your 2 cases. It will either crash or not, but it will usually print out a bunch of garbage. Okay, so that's what makes a string, is this null terminator at the end versus just a collection of characters. Okay. All right. So that's our string stuff. The other thing with string, and I'm not going to go through this because we don't really use strings that much, and I don't really care about strings that much, if you do have two strings, okay, so car A, hello, car B, hello, and you do something like if A equals B, that's false. Okay, and why is it false is because you're just comparing the memory addresses. Remember, A is a pointer to the starting memory address, B is a pointer to the starting memory address. Rick will have a lecture that has all the different string functions, but the only one we care about for this lab is string compare. Okay, and if they are equal in terms of their characters, it returns 0. Okay, and this is how we compare strings. Okay, with this string compare. All right, so let me just copy some of this lab across, and then I'll show you where that stuff is, and then yeah, that should be enough to get you going. Let me just check my phone. Blah, 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 blah. Cool. All right. So it gives you 3 of the 4 structs that you need to create. You need to create the last one, which is the system one. Create main, below the structure definitions, create an array to store the different types as belts as follows. So we've got struct belt type, which is the type, which is this one. We've got the name of the array, which is belt types. We've got the square brackets, 3, okay? So we've got literal 3 there. You could put a macro if you like. And then we've got an array, okay? And we've got, we've got an initialized array. So here, we've got the outer brackets here, which are talking about the array, and then the inner brackets, which are talking about each individual structure. And they're separated by commas. Now you'll notice this AT5, you'll notice you've got car, belt name, and it's got 6 there. This one here has 4 characters. Okay, AT5 and then the null terminator. But it's stored in 6, okay, because it should be able to store any of these. And then we've got the int, then we've got the float, then we've got the next float, and I left a line in there for some reason. Who knows why? And then I've got int, float, float, int, float, float, and the strings. Create a variable to store 5 characters, and then print to the screen, select the belt type, and store the user's input into it. So that's the string that we just talked about. Copy your search function from lab 6 and make the changes as below, and make sure to comment the changes. So here, things are going to be a little bit more different. So let me grab this. Oh, damn it. Cool. So we've got our search function. It looks similar to before, but we've got this string compare here instead. Now, the other thing you'll notice is that we've got struct belt type star here. Okay. Remember, with our pointers, if we want a pointer to a type, we have the type, then a star, and then the identifier. Okay. So we can have pointers to structs as well. Okay. Now, what you'll notice here is that we dereference the struct before getting the member inside of it, which is the belt name in this case. And the search is just as before. Okay, we're using pointer arithmetic here. If you wanted to use square braces, you could. And then we return the index like we did in the previous lab. And then what we got? And from there, what have we got? We have go back to main, call the function by sending the belt types array. Okay, so this one's accepts an array. Don't forget that whenever you see a star, the pointer can be to an array. Okay, so this is an array of values. We've got n and we've got our search value as before. But you'll notice that our search value is a string this time. Okay, so it's an array of characters ending with the null terminator. Handle the case of the function returning -1. Okay, so obviously if you can't find it, then you need to deal with that. Create a new variable of type struct belt specs. So this is now dealing with the belt. Set the type of customer belt specs to the correct belt type acquired in step 9. So this is a really cool step. Okay. So here we've got customer belt specs dot type. Now, if we go and have a look at that definition, dot type, this type is one of these. Okay. So you can have structs inside of structs, and we've got 3 belt types. Okay, we've got AT5, AT10, or AT20. And all we do here is the one that was chosen by the user is stored into that type. So we've got this belt spec that now has the type inside it. It has the number of teeth and the belt length. So it's got lots and lots of information inside of this one variable, not just 4 like an int or an 8 or a 4.2. It's got all of this information plus the number of teeth plus the belt length. So it's quite a powerful variable. We're going to see some even more powerful variables shortly. We're running out of room. We did run out of room. All right, from there, we set the belt length to -1. We create an array of struct gear specs of size 2, okay, which is called customer gears. We ask the user for the diameter of the first gear. So what is the diameter of the first gear? And set the gear pitch as the same as the belt. Okay, so whatever the pitch is of the belt, it gets set to the gears. Okay. You need to do this for the second gear as well. So you've got the user asking a question, you've got that scanf, and you'll notice that big bracket around everything, around that ampersand, because we want the address of this. We don't want the address of the struct itself. Create a new variable of struct timing belt system. And this is an extremely powerful variable because it has the whole entire system inside it. And then you're going to build that up. So you're going to grab the belt and put it in. You're going to grab the first gear and put it in. You're going to grab the second gear and put it in. Okay, and then you're going to get the center distance from the user. And that's where you stop, because the second task, you're going to actually calculate that. Does that make sense so far? It's a little bit to take in. How'd we go? Do we understand any of that? Was I just rambling? It's not as hard as pointers and stuff like that. It's a little bit annoying because of the obviously the type. You haven't seen this before, and remembering to put the brackets around. There are some things with the pointers that get a little bit confusing, but we're not really forcing you to use that this year. So, oh, actually, well, we kind of are, but we'll have a look at that. Okay. So we'll talk a little bit more about this in the labs. The first part's fairly simple. We will do this with pointers. There's a couple of little tricks with pointers with this. It's not as hard as pointers, the first pointers that we covered. But I'll wait till the lab to cover that. I'll have a go at this first before we talk about that. Because I think this is enough to take in right now. Is there any questions? Any problems? Any issues? Anything with the assignment that anyone forgot to ask? I think everyone's slowly leaving. All right. Well, thank you for showing up. I think this is kind of what everyone wanted was the assignment stuff. So hopefully that was helpful. Hopefully it leads to a good part 3. All right. Good luck. Unless there's any last minute questions, what I'll do is I will go have a 5-minute break, and if there's any questions in that time, I will answer them. Otherwise, we'll end it there. Okay, where's the